At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Selamat pagi, good morning everyone. I hope you are in a good condition because now we are going to start our second day of conference, the 2000 ASEAN Pacific Conference on Geoscience, Electronics, and Remote Sensing Technology 2020. And now, before I give this session to our moderator, I will inform you that the topic will be in this session is the role of information geospatial professional in new era. And our speakers are Dr. Insinyur Wijo Kongko, Magister Engineering from BPPT, Dr. Marina C.G. Frederick from BPPT, Dr. Osamu Kashimura from Japan Space System Hyperspectral, and the fourth one is Dr. Halda Aditya Belgaman from BBTMC BPPT, and the fifth is Dr. Violeta Marvel from BPPT. The sixth one is Professor Wataru Takeuchi from University of Tokyo, Japan. And the seventh is Amelia Shafitri from Maxar Technology. And the eighth is Dr. Thomas Hitch from EOMEP, Germany. And the ninth is Dr. Irwan Melano from ITB. And the last one is Dr. Damian Glossa. And now, I will inform you our moderator for today is Dr. Heri Satmono. And this session will begin from Dr. Heri Satmono. Please, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Good morning, everyone. Welcome to all honorable speakers and participants to this morning session, the 2020 IEEE Asia Pacific Conference on Geoscience, Electronic and Remote Sensing Technology. My name is Heri Satmono. I'm from BPT. I will be your moderator for this morning session. And this morning session topic is about role of information geospatial professional in new era. Already mentioned by Zilda, we have 10 speakers from various countries, and each speaker will have 20 minutes, 15 minutes for present, and 5 minutes last for discussion. Without delaying more time, I hope all 10 speakers already in the virtual room, so we can start now with the first speakers, Dr. Insinyur Widya Kongko, MN from BTIPDP, Yogyakarta, Indonesia. Pak Widyo, mohon bersiap. I will read Pak Widyo Curriculum Vitae, the short curriculum vitae. Pak Widyo Kongko from Banyumas, and now he is head of Laboratory Technology for Harbor Infrastructure and Coastal Dynamics, BTIPDP BPT in Yogyakarta. He's got his master degree from Iwate University, Japan, and his doctoral degree is from Gottfried Wilhelm Leipzig University of Hanover.
So I will share then the presentation. So the title is Artificial Neural Network for Tsunami Forecasting. In the first time we use with the South Java Indonesia case. So this is the introduction. I think be aware with the Indonesia tectonic setting. So our Indonesian archipelago lying in the very very vulnerable in terms of active tectonic. So this is the figure shows that our Indonesian archipelago lying in the three plates with a convergence rate annually about 7 to 11 centimeters. So again, in the 2017, Pusken published the earthquake hazard and the sources map, and established the Indonesian megatrust, which are now we have at least certain segmentation of megatrust that can generate at least magnitude 8.5. So along these trenches, we have very long trenches, more than 3,500 kilometers in the Sunda Arc, and also in the in the Malukus and the north of Papua. So we have 95,000 kilometer of coastline, and 50 to 60% of this coastline prone to tsunami with a very high probability of megatrust earthquake generate a tsunami with 10 to 15 meters of height. So this is the historical event of earthquake in the 400 years past. So we have more than magnitude of 7, about 230. So this is the historical event so far. And we have also the historical event of tsunami, about 400 years. And the destructive tsunami, about 50% of 100 more and less events since 16th century to present, and mostly 70% or 60% to 70% due to the tectonic, so tsunamigenic earthquake, and the remaining about 30% non-tectonics, such as flank collapse, eruptions, submarine or aerial submarine landslide, and some we haven't even don't know the sources till now. And this is the statistical victims of multi-hazard. Almost similar in the Indonesian statistic, multi-hazard and globals, especially due to the earthquake and tsunami. So two events dominant, yeah, very, very dominant, about 55 to almost 60% caused victims or death, yeah, or loss of life. And yes, we already established on November 11th, 2008, the tsunami early warning system. This is inaugurated on 2008, and the two goals, the main product of INAT TWS is earthquake information and tsunami warning. So within less than 5 minutes, even since last year, the, 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 the target is more and less 2-3 minutes. So we will have information from BMKG, and then this is information should be disseminated to communities within 5 minutes. And the infrastructures end-to-end of in a tsunami early warning system consists of mainly two things: upstream and downstream. So upstream, the integrated sensor from seismic, earthquake, tsunami, with land and sea platform monitoring system like buoy, OBU, tide gauge, and as well as, of course, from BMKG itself, hundreds of seismograph, accelerometer, and so on. So this is then processing, and then monitoring, processing, and dissemination to the downstream to local or national institution like BNPB, BPD, and so on. But yes, the challenge is what we call in tsunami science is the estimated tsunami arrival. From after earthquake, and the tsunami will propagate to the shores or to the beach and reach the beach and the communities, all assets in the coastal infrastructure, and so on. So we should make a very careful about the estimated tsunami arrival time design. So this is very, very crucial. Yeah, to estimate or to measure the estimated tsunami arrival, the best method is using model, but we have a very huge area, so we can use another method, very simple, with analytical calculation estimates. So this is the approximately estimated time arrival. For example, we use 16 megathrust as a tsunamigenic earthquake sources, and this all segment and assumed or estimated the geometric design, length and width of fault plane of megathrust, and the target magnitude more than 8.5 in some places like megathrust of Banda, but 8, so 7.5, something like that. And then we estimate the tsunami travel time. Well, 5 or 2 minutes to 30 or 50 minutes, so very, very short. Yeah. So this is the tsunami travel time, but we should take into account about also the processing, early warning system processing at PMKG and the community response. It takes about 5 to 10 minutes, or average approximately 7 minutes of time like that. Yeah, to pass on the study in BNPB. So the time level available, or we call it golden time, is really very short, about less than 15 minutes. The second, we try to exercise of artificial neural network. So because of a very limit, or we have a very short time of golden time, so we think that by using artificial intelligence of tsunami, we could provide fast and accurate of the especially the tsunami height and estimated time arrival in the coastline. So firstly, we developed the tsunami model for INN trainers. For sure, yeah, we use a tsunami, and we also study with the previous experiences from colleagues like Mase, Kumar et al. And Romano. So the result, yes, any predicted result range from 94%. So this is indicating a high reliable method, yeah, for the ANN. And comparing with the field survey, the error but 25%. So this is also more and less similar with the tsunami model compared to the field observation in many cases. And to produce the INN forecast model is only very in the few seconds. This is very, very short. After, of course, after INN tsunami already trained, yeah, and then giving the test. So will feedback the result only a very, very few seconds, and the accuracy is also, well, high, similar with the model. This is the result of the previous study, and we try to exercise with the South Java. We give the input in some epicenter like dots, red dots there, and we take the result along the coastline point of observation, more than 120 in the coastlines. And this is the result of the trainer. And then we after that after training, we validate and we test with the performance more than 95% with the validation testing, and this is the graph depicted here. The IN we we are developing now. The input layer still very limited about the magnitude from 6.5 to 8.2, something like that, yeah, with some interval. And then the input layer, we use epicenter and magnitude parameters. So this is the anatomy of the INN. And we here the tsunami prediction using INN compare with the model. So I think it's small, but yes, green and red graphs there almost similar. So we get the best fit with the model comparing with the INM, yeah. With some case 1, case 2, and case 3. So I'll assume that 2 Indonesian coastline more than 50% prone to tsunami of megathrust earthquake, with the maximum height of tsunami about 10 to 15 meters in the coastline, and the tsunami several times very short, about 15 minutes. So tsunami early warning system really challenged. So we thought that the island can be useful to understand the tsunami early warning system performance. The second, we used already the case for South Java for by using INN for tsunami forecasting. We conducted already training, validation, and test, and the result similar with the previous study, about 2% and about 5% of relatively error, and this is I think best fit with the compared with the modeling result. So I think this is the last my last slide. So outlook is still we are developing now the tsunami model channel to get huge data sets of tsunami model with a higher magnitude, and we varies with the depth. Hopefully in the next year will be finished all in the Indonesian area. I think that's all. Thank you very much. Yeah, thank you very much.
Afternoon, Pak Widyo. Thank you, Pak Widyo. Pak Widyo just present about artificial neural network for tsunami forecasting in South Java. Thank you for your brief presentation, Pak Widyo. We have 4 minutes to 1 or 2 questions from audience, please. Suaranya sudah terdengarkah? Sudah? Baik, suara saya sudah terdengar, Pak Komite? Okay, thank you, Pak Widyo, for your brief presentation. Your presentation about artificial neural network for tsunami forecasting in South Java. We have still 4 minutes. Maybe 1 or 2 questions from audience, please. It's too early in the morning. Okay, Pak Widyo, once again, thank you for your presentation. We will move to the next presentation. We jump to the third presenter because Dr. Marina will present in the end of this session, morning session. The third presenter is Dr. Osuma Kazimura from Hisui Hyperspectral Image Suite, Japan. Pak Hashimura is now Deputy Director General at Remote Sensing Division, Japan Space System. Director General, Research and Development Division, Japan Space System, will present about Hisui Hyperspectral Imager Suite current status. Pak Hashimura, you have 20 minutes, 15 minutes for your presentation, and 5 minutes for discussion. Pak Hashimura, the screen is yours, please.
Yes. Thank you very much. Can you hear me?
Ya, Pak.
Okay. Thank you very much for introducing me. And good morning, ladies and gentlemen. I'm Osamu Kashimura of Japan Space Systems. First of all, I say thank you very much for everyone of organizer of AGERS 2020, especially Dr. Augustin and Dr. Fiorenta to invite me as a speaker. I'm working in Japan Space Systems. That is a non-profit organization mainly conducting satellite development, data utilization technology development, and many research projects, mainly contracted by Japanese government, such as METI, JICA, and the Cabinet Office. Okay, Hisui is one of the project. I'll share my slides. Okay. Share. Yeah. Okay. And Hisui is the one with jointly development project of METI and us. Today, I will introduce Hisui and its current status. Okay. Hisui was launched from a US Cape Canaveral Air Force Base toward the ISS International Space Station on December 6 last year. The photo on top of this slide is the Dragon carg, just separated from Falcon 9 rocket, and just showing a Hisui under the Dragon carg. 1 week later after the launch, Hisui was successfully installed to Kibo's exposed facility. And what is hyperspectral data? Here is the typical difference between the multispectral data and the hyperspectral data. The left figure shows the spectral bands of multispectral sensor. As the data is an example. There are 9 spectral bands between 0.5 and 2.5 micrometers, and between 2 and 2.5 micrometers, there are 5 bands. The spectral band of Hisui here is shown in the right figure. As an example of the hyperspectral data, the number of spectral bands is 185 between 0.5 and 2.5 micrometers, which is about
Excuse
20
me.
times that of Aster's
Excuse
9
me,
bands.
Dr. Kashimura. We'd like to inform you that the slide that you are presenting is not like what you're saying. So it needs to be updated.
Really?
I mean, yeah, it needs to be on the. Yeah, you need to share the slideshow, please.
I try again.
Okay, thank you.
Okay. This share my slides.
Yes.
Okay, thank you. So sorry, I forget my spectral sensor. Okay, so a hyperspectral sensor observe the Earth, the continuously wave bands. Okay. Okay, this is history specifications, detailed specification, but it's a little bit complicated. The main points are the spectral bands is 55 bands in the VNIR, visible near infrared, and 127 bands in the short wave infrared. And the spectral resolution 10 nanometer for VNIR and 12.5 nanometer in shortwave infrared. Okay, this is a HISI schedule. Now we are in the stage of the end of initial checkout and just starting the pre-nominal operation. The pre-nominal operation means that data acquisition operation is nominal, but data product is not automatically. So we are now under development that the HISI ground station development system will start the system from the next April. So next slide. And this is a one-day observation of HISI from the ISS during one day. ISS goes around the Earth about 15 times per day. And HISI observed the Earth in colored parts of this slide on the several orbit. Observation on the orbit is divided into maximum 3 segments, but maximum observation time per orbit is 8 minutes. And the red color on the orbit and the yellow color and the green points, those are the 3 segments. On white line, not the observation location, and the gray line is the night time, and the purple line is that the sun angle is less than 40 degrees, not good, suitable for observation. After 3 years, history will be obtained almost land coverage all over the world. This is the number of cloud-free observation, and white color means that unfortunately this is not successful or good scenes due to the cloud. And the purple, and depending on the color, how many times could be successful to obtain the good clear imagery from HISI. And after 3 years, such kind of red areas on the right bottom figure show that priority regions. These priority regions, 65% after 1 year coverage, and 85% coverage for the second 2 years later, and 3 years later, 92% will be covered. And the global mapping in 45, 67, and 76 respectively. And last September, using the data acquired from the instrument commissioning phase, a demonstration processing has been conducted, and the first light image is introduced as a news release on our website. This is a natural color image acquired by Hisui over New South Wales in Australia on September 4th, 2020. More detailed information is here. Please see our website. Since 2007, we had been conducting the various application studies using the airborne hyperspectral data over not only Japan, but also in Asia Pacific regions in order to promote the utilization of history data. In the natural resources sectors, it is possible to recognize the distribution of many mineral deposits that are important indicator for oil and gas and mineral resources exploration. Other applications, like agriculture, including monitoring of the status of crops and the soil in the agriculture sector, and a detailed classification of important forest and vegetation carbon dynamics in the tropical peatland, and soil salinity in the environmental sector. New information from hyperspectral data that is not available in the multispectral data will be obtained. So hyperspectral data is expected to be used in a wide range of sectors. This is one of the applications. BPPT and we, Japan Space Systems, former the name is AirStack, has conducted 7 years research and development joint project to achieve the hyperspectral data in practical use and support to food security issues in Indonesia. Key items that to estimate the harvest time in the paddy field and the yield estimation before harvesting. The name of this project was Hyper3. I guess more than 20 staffs of the BPPT jointly conducted this project, and many people of those staffs participate to this AGERS 2020, I think. In Indonesia, agriculture water is supplied from the area closest to the inland mountainous dam, and the growth stage information is needed to estimate the harvest time. The growth stage is distance from the water source. This growth stage information is needed to estimate the harvest time. In the growth stage map, such as the left figures, also create a yield estimation map in the right figure. This is output, so one of the output of this Hyper3 project. And another application of the capabilities of hyperspectral data. And this application field study was done using the airborne hyperspectral data, and such kind of rocks and minerals has a very specific absorption in spectral signal. So spectral feature is used to identify minerals. And the distribution of minerals is strongly related to the natural resources. One of the features of hyperspectral data is narrow and continuous wavelength band than existing multispectral data. So detailed information of absorption bands of minerals is very, very, very important to explore oil and gas and mineral resources in efficiently and effectively. Okay. And this is another example of the application that the coral bleaching. Coral bleaching is rapidly progressing around the world, and the water temperature is rising due to the climate change, I think. So if the bleaching condition continues for a long time, the coral will die. Knowing whether a coral is recovers living or died, this is very important for the local economy and the biodiversity. Hyperspectral data can be used to determine whether a coral is alive or dead by capturing a slight differences in the spectral data. It can be used for coral reef monitoring and expected to be useful for coral conservation. And next is one of the applications of bathymetry. Okay. Using hyperspectral data, such kind of estimation could be available. In our research, we have developed a method that can estimate water depth up to about 20 meters from the hyperspectral data. This figure is an example of a water depth estimation in one of the islands in Okinawa. The water depth is distribution tendency is almost the same. The center figure is the exact water depth, and the right figure is the estimation from hyperspectral data. Such water depth information is expected to be used in fisheries, ocean energy development, and coastal conservation and the tsunami simulation. And another example is that the potential capability of a hyperspectral data is that the degradation of a peat swamp forest. In central Kalimantan, large amount of carbon dioxide is emitted from peat swamp forest by a wildfire or cultivating. We have to measure, report, and verify the amount of carbon dioxide emitted from those land covers. And the hyperspectral data is used to estimate biomass and to classify peat swamp forest into primary and secondary forest according to the forest type defined by the government. Furthermore, our measurement on forest type is useful to evaluate biodiversity in the forest because of high biodiversity in primary forest. And this is a new topic of our project. And UN SCAP has started Closing the Loop project to scale up innovation to tackle marine plastic pollution in Asian cities.
Pak Kasimura, you have 4 minutes more.
Okay, just 3 slides. Japan Space Systems is involved in this project to develop ocean source digital tool, open source digital tool. Since we have developed WebGIS system and a smartphone application for managing geospatial data in various projects. Collecting plastic waste data has been studied by a smartphone with multi-stakeholders. Collected data is managed by WebGIS, and local government can access to the data over the internet to make action plans, strategy to reduce plastic waste from the cities. And this LCTF camera is very, very important for such kind of plastic monitoring from the drone or small satellite constellation. Since plastic has a yellow line specific absorption band, and this camera using several LCTF liquid crystal tunable filter that capture these specific absorption band. So history hyperspectral data will enable new information extraction in various fields, and this hyperspectral data plus LCTF camera for plastic mining and others is very, very useful to utilize those project. Summary, final slide. History was successfully launched last year, and now is just the initial checkout phase. And history data will be distributed to scientists worldwide under the framework of history research announcement from next year. And please contact history application at Mark J Space Systems or JP for more details. Yes, thank you very much. I'll finish.
Pamukos Kasimura for your brief and colorful presentation. Your presentation is about HISUI, Hyperspectral Imager Suite in the current status. We still have 5 minutes for discussion. I will let Pak Agustan. Loh. Pak Arifin Nugroho, maybe have a question, please.
Hello. Hello, good morning. Hello, good morning. Can I ask a question?
Hello. Thank you very much for for allowing me to ask something. I would like to appreciate presentations of Kasimura-san. We would like to know what will be the possibility for cooperating closely with your organizations, and what sort of cooperation that we could explore in the future, especially with regard to the varieties of data that can be gathered from the systems, and what sort of algorithms that might be of interest for communities in order to explore more about the environment and the resources, as has been explained by Kasimura-san. I just would like to know in general what will be the possibility to such cooperations in the future. Thank you.
Yeah. Thank you very much. And we have many options to collaborate in the future. So, of course, this project will continue more than 1 or 2 years, depending on the Japanese government decision, that those data will be available to use for scientists, especially for scientists in probably free of charge, I don't know. So please contact to our website or email site history_application at JSpace Systems or or.jp for the future possibility to collaborate. Thank you very much.
Arifin dan Pak Kasimura for your discussion. Another question is coming from Princip.
Yes.
Please.
Thank you very much. Yeah. Yeah. So,
Okay,
Kashimura-san, thank you very much for your wonderful presentation. I'm very interested on your presentation. Specifically, what would be the specification of the L1 product that we'll be releasing to the public?
Sorry, I don't have a slide today, but L1 product is that after calibration, radiometric correction, and there are two L1 products. First one is L1R. L1R is just a radiometric correction, and L1G is a geometric correction. So you can use the L1G to your GIS systems very easily. So there are two products.
Thank you. And my other question is more on the request of data. Let's say, since this is hyperspectral, does the user need to specify the wavelength range we want? Or there is already specific wavelength range for a band image, or there is already predetermined wavelength range per band?
Okay. History has a 185 bands. So you can get at once one data 185 bands. You can select any wavelength bands from the 185. But on the other hand, I introduced the last slide that the LCTF camera that has almost 10 specific bands. You can select this what kind of wavelengths could be acquired. It depending on the user requirement. So you can select any wavelengths because not 185, just 10 or 12 bands. So you can select selectable and tunable wavelengths.
Thank you very much.
Thank you.
Please, for the discussion. I think we will conclude this session. Once again, thank you very much, Dr. Osamu Kasimura. Big applause.
Thank you very much.
Okay, the next speakers will be Dr. Halda Aditya Belgaman, SSE MSM from BPTMC BPPT. Please prepare your materi, Pak Halda. Pak Halda will present about mitigate forest fire using weather modification based on artificial intelligence. Pak Halda has a master degree from ITB, doctoral program from Kumatomo University. Have several projects in weather modification. Pak Halda, you have 20 minutes. 15 minutes for presentation and 5 minutes last for discussion. Pak Halda, the screen is yours.
Thank you, Chairman. To share my screen. Is it? I think it's visible for to see. Thank you again for the opportunity for me to represent the weather modification technology national laboratory unit to present the research and development in the term of forest fire prevention, how we mitigate forest fire using weather modification based on artificial intelligence. And my name is Halda Aditya, and I am one of the staff at the National Laboratory for Weather Modifications Technology. So the outline of my topic, I will talk about the background, what is the weather modifications, and who are the forest fire stakeholders in mitigate the or to prevent the forest fires. The second one is I will talk about the data, how we explore the data, what data we are using. Third one, I will talk about the methodology, what insight we get from the data science experiments we did in the office. And the last one is the models and the applications we built. So for the background, the introductions, maybe some of you have heard the weather modification technology, maybe some dozens. So by definition, the weather modification technology is the interventions on the cloud development process for enhancement or suppressing the rainfall intensity. In Indonesia, the weather modification technology or the TMC were used to rain enhancement, rain suppressions, and also for fire suppressions. And how we intervene the cloud process, how we intervene the cloud growth process, as we knew that the cloud form, the first stage is for the evaporations, where the water going from to liquid to form a gas, and then the condensations. The aerosols in the atmosphere interact with the water vapor in the atmosphere that form the cloud droplets. These cloud droplets will then form into the rainfall droplets that falls from the clouds into the earth's surface. The changing of the cloud droplets into the rainfall droplets happens with several processes, namely coalescence and coalescence. So they collide each other, and then they combine each other, then become bigger and bigger, and then so the rainfall droplets are formed. In this stage are the process we intervene with our cloud seeding agents. We introduce the cloud seeding agents into the clouds to speed up the process from cloud droplet to the rainfall droplets. In Indonesia, the weather modifications operations started in 1979 until now. We do various kind of activities for the forest fire mitigations, irrigations process, the floods mitigations, and also for the rain reduction for a mining area. This kind of process we are do the operations. So in terms of the forest fires, as we all knew, the hotspots occurrence over Indonesia are mainly happens in the dry seasons, and each year the numbers is still increasing. So the National Laboratory of Weather Modification response users, in this case the National Disaster Agency and the district level disaster agency, the BNPB or the BBBD, to mitigate and forest fire every year. But however, the timelines of the implementations become a problem. We often asked to do the weather modifications operations in the peak of the dry seasons. we all knew, the peak of the dry season have lower relative humidity and also low convective activity. So the potential clouds are rarely found. So it is difficult to find potential clouds in the dry season because the cloud seeding operations then become less effective. The best time to do the cloud seeding operations is in the transition season from wet to dry season or from dry season to the wet seasons. So why it becomes a problem? Because the process of doing such weather modification operations started at the district government or the provincial level governments. They need to make some emergency status of their province. That their province is prone to the smokes from the forest fires. In order to do that, first they have some meetings and then they evaluate that is there any hotspots, if there are any hotspots, how many the hotspots are, and then they officially state that their province is in the dangerous level of the forest fires. Then they send letter to the BNPB for the official request for the weather modification activities. In the BNPB then makes the request letter to the BPPT for us to do the weather modifications activities. So this long process resulted in a long time. So when we are approved to do the weather modifications, it's already very dry conditions in the locations. So sometimes the operations become not so effective. So from that, we have some visions to develop some tools to make this cross-functional forest fire fighting force, the weather modification team or our team, the BNPB or the BPB, the agency, to make optimized decisions to prevent forest fire based on evidence-based predictions of the forest fire situations. So we changed the paradigm that usually the weather modification done to extinguish fire from the hotspots, but it's more effective if the weather modification used to make the peatland more wet or rewetting the peatland. We can do the rewetting of the peatland in the transition seasons. So if we can provide our team with the ability to make evidence-based recommendations in advance, we can increase the confidence level of the team. We can enable our team to plan an effective proactive measure. So we can directly tell to the district level disaster agency or the national level disaster agency that some area have very dry conditions for the water level, that we need to plan for the weather modification activities in the futures. Second one, I will talk about the data. We explore the data, how many tools are available today to monitor and prevent forest fires. Every institution in Indonesia, especially related to the forest fire, have so many tools for monitoring the hotspots or the peatlands conditions. BPT has the peatland monitoring water level, and also we have INA-FDRS developed by the PTPS team. The KLHK have the Sipong to monitor the hotspots. APAN also monitoring the hotspots and the operational levels, while BMKG have the weather and climate forecast data. Also, they have the FDRS index to monitor the fire danger ratings and also the hotspots conditions. Recently, they developed the application to forecast the hotspots in 6 months ahead, while the BRG or the peatland restoration units have the applications and sensors to monitor the water levels. So from all these applications, we need to build some new applications that have capabilities to forecast the water levels to help us in the weather modification teams to determine when each area the water level is decreasing. So we need those kind of capabilities to plan the better weather modifications operations. So we design this application need to be can forecast it in the mid or long term, 3 to 6 months ahead. So we are using the Peatland Restoration Agency, or the BMG, water level data. They have data across Indonesia. They have total number 174 number of total stations, divided in more than 6 province stations, but we only use 6 province stations data that prone to the forest fires. Meanwhile, from 174, only 19 stations that actively sends the data to the servers. From the dispersions of the stations, Riau province have the highest number of stations compared to other stations. Number 2 is the Central Kalimantan province, while other provinces only have 12%, 8%, and 4% of stations numbers. The methodology we use in this research, we are first, after we identify the data source who have the data, then we analyze those data. We analyze seasonal climate forecast from the BMKG and others data, and also we analyze the peatland conditions. We also have make analysis of the hotspots.
Pak Alda, 5 menit lagi,
Yeah.
Pak Alda.
Yep. Sure. And then from this analyzing, we analyze the hotspots correlations with the water levels, and also we build models from the peatlands data. This is the steps of our building model. First, we pre-process, then we do the seasonality analysis. We fit the model and evaluate the models, and then we predict using the models with it. Just the examples of the water level data from 2019 to 2020. And this is the pre-process stage. We process 6 province stations, 50 stations. One station has around 50,000 lines of data. Then we need to process more than 2 million lines of data. This is the examples of the seasonality analysis. We need to see if the data we have that have some trends. This is the station we pick to fit the models and analyze the models. Then we see the smallest error value of the models. In the time frame last month, we only analyze 3 models and 3 algorithms to be fitted to the data. So from the algorithm, we see that the ETS of exponential smoothing have the best performance compared with other models. The average value of this ETS model is around 0.23 for all selected stations. After we get the models, then we analyze the historical condition of the precipitations. For example, we knew that in Riau province in February there will be drops in the water level. We see if the precipitation amounts in February historically is available for us to do the cloud seedings. And before February, which month we can do the weather modification operations, for example, in January or in December. This is the hotspot cluster analysis. Maybe we develop clustering analysis to see the relationship between the water levels and also the hotspots appearance. This is need to be done for us to see the critical level of water level in each station. Each station described very differently based on the peatland characteristic. Each peatland have different unique characteristics. For example, in Okipu stations, the number of hotspots cluster will rise after the water level is in below 0.4. Meanwhile, in Sele, the threshold is we observe in only 0.08 meters. So this discovery will benefit us to provide highly accurate information for forest fire prevention decision through the weather modifications operations, and also will help the scientists or the flight scientists to better understanding peatlands behaviors, then decided which area need to be executed or need to be sits the clouds above it. And this is the applications. With the forecast, we can make early decision to inform relevant stakeholders for weather technology operations to prevent forest fires. I think. Thank you, Mr. Chairman. I think that's all my talk.
Matur nuwun Pak Alda. Thank you very much Pak Alda for your very detailed presentation. Your presentation is about mitigate forest fire using weather modification based on artificial intelligence. We still have a little bit time. Is there any question from audience to Pak Alda? Committee, is there any question? Not yet. Slido? Not yet. Okay, we will conclude the session. Once again, thank you, Pak Halda, for your presentation. We will go to sami-sami, Pak. We will go to next presenter, Dr. Violentina Marpaung from Violinta Marpaung, sorry, from BPT. Mbak Vio is young rising star from our institution. Will present about Center for Excellence in Science and Technology, Natural Resource Counting. Dr. Vio has master degree from National Central University, Taiwan, and has doctoral degree from Hokkaido University, Japan. I present you Dr. Violentina. Violenta.
Okay, I will share my presentation slide. Wait a moment. Okay, is it clear? My presentation is showing, committee? Good afternoon, ladies and gentlemen. It's a pleasure to have you here by offline in BPPT building in Jakarta, and also by online virtual Zoom meeting, and also from YouTube. And again, good morning, everyone. I am Violenta Marpaung, a researcher from BPPT, PTPSW, the Center of Technology for Regional Resources Development. So today I'd like to present about the PUI. We call it in Bahasa PUI, Pusat Unggul Iptek, or in English we call it Center for Science and Technology Excellence. And my talk will briefly show you about the PUI-TASDA, the Center for Science and Technology Excellence, Natural Resources Accounting, which is in our division PTPSW BPPT. So in my today talk, I have two parts that I will explain. First is what is a PUI, the Center for Science and Technology Excellence, and the second is the Natural Resources Accounting PUI in our divisions. Is my voice clear? Okay, so what is a PUI? PUI is the Pusat Unggulan Iptek, or Center for Science and Technology Excellence. In 2016, the Ministry of Science and Technology Republic of Indonesia have promoted PUI. So by the definition, is the PUI is the center, is the organization that has formed at least the last 3 years, both independently and in collaboration with other organizations, or we call it consortium. So the organization should carry out the international standard research activities in multi-specific and interdisciplinary field with very high standard of result and also relevant of the needs of science and technology users. Next. Internet. Sorry, there is a connection. Next. Gak bisa. Internetnya jelek di sini. Sorry, there is some technical issues. Okay, so what if we get the PUI, we have some benefits. So the first benefit is to obtain operational incentive fund by for development of for our research from the Ministry of Science and Technology, and the fund should be 10% is from its institutions. The other benefit, if we got the PUI, is we got the priority to get other incentive program in the Ministry of Research, Technology, and Higher Education. And also, we will obtain the institutional guidance with the aim of improving the performance or output of research and development institution so as to contribute more in economic growth and improving the social security of the community. Next. So in PUI, we have 11 clusters. First, like maritime, energy, food and agriculture, transportation, telecommunication and informations, and defense and security technology, health and pharmacy, engineering, materials, social, culture, and humaniora, policy, and the last is the mitigation of disaster. So this cluster already classified in PUI. Next. Have the PUI. So about 40% in government agency, both in ministerial government or non-ministerial government, and 5% in enterprises company. Next, please. So the total PUI in Indonesia, this slide shows in government agency. So before, please. So we have 42 non-ministerial government agency, 50 institute of government agency, 7 enterprises, and 27 university. So one of that is a BPPT, the Center of Technology for Regional Resources Development, and also the division of Sentra Teknologi Polymer in Serpong, BPPT, Indonesia. Next, please. So in the PUI, we have 3 components. First is the sourcing and absorptive capacity. Inside they have 15 criteria, which is include input, process, and output. And the second is the research and development capacity, which have 8 criteria that include process and output. And the last is the disseminating capacity with 8 criteria with outcome and impact. these components should be fulfilled to guide to make the institution have this PUI established in their institutions. Next, please. So next slide, I want to introduce our PUI TASDA, or in bahasa we call it Pusat Unggul Iptek Teknologi Akuntansi Sumber Daya Alam, or Center for Science and Technology Excellence Natural Resources Accounting. Next. So maybe some of audience already know what is PTPSW is or BPPT is. So our division called PTPSW, or the Center of Technology for Regional Resources Development, have three main duty and function. First is to implement of the assessment and application of technology in the field of natural resource exploration based on an advanced remote sensing approach. Second is exploration of terrestrial natural resources based on the advanced geophysics. And the third is the natural resource exploration of marine and coastal area based on the acoustic tomography. The second function of the PTPSW is to prepare of the technology policy formulation for regional resource development. And the last is to implement of planning, monitoring, and evaluation program and budget evaluation in our division. Next. So among the institution in PUI itself is required there is a synergy among the institutions. There is two types. We call it synergy level 1, where it's synergy activity that support the excellence of the institution itself. L2 is to support and meets the needs of the other institutions. In our PUI TASDA, with the cluster disaster mitigation, we have all these level 1 and also level 2. So since 2017 up now, we have synergy among institutions such as Ministry of Environmental Forestry, LAPAN, BMKG, Meteorological, Climatological, Geophysics Agency, and also BRG, Pit Restoration Agency. So we have specific collaborations among those institutions, such as with MOEF, Ministry of Environmental Forestry. We have environmental quality. We have synergy with the environmental quality improvement, disaster mitigation in river flow areas. Where in LAPAN we have collaboration or consortium with the Center for Science and Meteorology, and also collaboration with remote sensing and data sensor. While in BMKG, we have collaboration research in hydrometeorological and tsunami modeling. So what is activity in the PUI or in our division is PUI TASDA. It consists of 5 activity flow. First is the input, process, output, outcome, and impact. So what's the brief explanation about the activity? First, the input, we have to increase the manpower of our human resources in our institution. And in the process, we should have accredit our product, and as an output example, we make a collaboration research with others agency, both in national and international. In national, we have a collaboration with, like I say, BRG, BMKG, LAPAN, Ministry of MOEF, Ministry of Environmental Forestry, and also LIPI. While collaboration in other country, we have JICA, RESTEC, and also Hokkaido University. One of the impact of activity in PUI TASDA, we have a good national appreciation and recognition while we launched our product in 2018 and in 2019. So this, I will briefly show the criteria of the source and outsourcing capacity. We can see from the slide. Next. Sorry, most of them in Bahasa. So in this criteria, there's 15 criteria that mostly we already accomplished, such like we already have SOP and we have a good human resources, while the ratio of the fund in research fund is roughly about 50 million rupiah per person in our division. Next. And also we also already got the ISO 9001 since November 2018, and we active join in the scientific international conference such as like this, IEEE, and also American Geophysical Union, and others information. Next. Next. For the research and development capacity, they have some criteria. First is we have research activities such as INA FDRS is the Indonesia Forest Fire Danger Rating System, Sipalaga sistem informasi pemantau air muka lahan gambut, software of TEV, technology of economic valuation for peatland in specific PHU, peat hydrological unit in Central Kalimantan. We also have some intellectual rights such for the TFV, KSA, kerangka sampel area, and also Sipalaga. And also we still improve the project such as INA FDRS, Sipalaga, and the TEV, the total economic valuations, collaborate with the BBM, Balai Besar Teknologi Modifikasi Cuaca BPPT. Next. Next. So the last is the dissemination capacity. We have several criteria. Next. So our product already used with another stakeholder, and we also have some collaborate with, like I said before, collaborate with BMKG, KLHK, LAPAN, IPP, the university, Peat Restoration Agency, and C4 for the improve the product of our research. Next. So we have also, like I said, our product already be implemented in the organ Komiring Ilir in Riau province. This is a sample of our product. It's called Sipalaga, Sistem Informasi Pemantauan Air Muka Air Lahan Gambut. So we have the Sipalaga interactive, Sipalaga monitoring, and also based on Android, like we say on the screen. And the Sipalaga also already installed in the presidential office, so the president can monitor directly the what is the condition of the peat in Indonesia. This product is collaborated with also with the BRG, the Peat Restoration Agency. Next. And the last is our product also. You can access in the website I show in below, inafdrs.ptpsp.bbpt.go.id, where we can monitor directly the fire danger rating system In this, we have one study case in Ogan Komering Ilir, in South Sumatra. So that's for my presentations. Thank you very much.
Terima kasih, Dr. Vio. Thank you, Dr. Vio, for your very brief presentation. Your presentation is about Center for Excellence in Science and Technology, Natural Resource Counting Committee. Is there any question from floor, from audience? Is there any sign? No sign. No sign? Okay. From Slido, still no question. We will go to next presenter. Our next presenter is Professor Wataru Takeuchi from Tokyo University. Professor Wataru has all degrees from Tokyo University, and now he is a professor, Institute of Industrial Science, the University of Tokyo. Professor Wataru will present about geospatial technology toward one world, one health, and one earth. You have 20 minutes, Professor Wataru, and 50 minutes for your presentation. Screen is yours, please.
Thank you very much, Mr. Chairperson. And good morning. Good morning to all. So I'm happy to be here and appreciate the chances to talk on spatial technologies toward one world and one health and one earth. So today's my topic is a rather broad topic, so that start from this slide, which address the global commons. So the global common is terminology, which refers to land and water, which we humans, also the animals, all over the world share as a community. So that, as discussed in the Sustainability Development Goals, so that this global commons, how to utilize this as a sustainable way, including cyberspace, is becoming a very important issue. So regarding this, earlier in 2004, there was one statement done by the scientists in US and Europe. It's called the Manhattan Principles and One World, One Health. So left-hand figure shows the concept of one world and one health, as maybe collectively called as one earth. So one world stands for the ecosystem in our human world, and also one health stands for animal health and human health. Those environmental issues of our earth, including terrestrial ecosystem, ocean and atmosphere, and our humans' health and animal health, who live in the earth as a global commons, to be treated as equally. So right-hand figure shows another way of conceptual proposal and centered on well-being. And those numbers are corresponding to 17 SDG goals. So centered on our well-being, and especially in our urban life, social infrastructures such as roads, transportation, energy, and etc. is included. Then we are also surrounded by the natural environment, and all of those need to have good balance under the development. So, but in our focus on our human activities, we also understand the importance of environment, but we also need to consider our economic activities as well as social issues. Social issues, environmental issues is such a mitigation strategies or the policy making is fully done by, especially for the land applications, done by those independent countries. They have their own policies. Among scientists, maybe scientific research has no border, but social decisions and policy making is fully depends on the governmental policy. And also the economical development stage is very much depends on the countries. So that such the nexus or the balance between environment and the economy and social, we need to have good balance between them. So there's one index, most of might be known, to evaluate ecological footprint and to address the environmental capacity of the earth. Is mostly includes forest and products and carbon footprint and cropland and grassland and pastures and built up land and fisheries. Mostly those areas where we live has we give some impacts on the earth. So that ecological footprint consumption is computed with some parties by remote sensing measurement, some parties some supplementary data in like laws or factories built up area. Those, but I do not go into the detail, but such ecological footprint and biocapacity, the balance between capacity and footprint or impact could be computed in somehow. Then this is a map produced by the Global Footprint Network. And red color shows ecological footprint is bigger than the capacity. So like our country, Japan, for example, Japan and China and India and Bangladesh, or Thailand, Vietnam, those countries are in red colors. So your country, Indonesia, is not in red, so which has relatively lower impacts over the regions. So as you will see, so that a lot of red color was seen, not only in developing countries, developed countries like US or in European countries, but also in developing countries, India, some Vietnam, or North African countries are already in red colors. So those human kind of welfare or the well-being and ecological footprints are in positive relations. So x-axis shows a human development index. It's kind of indicators of human welfare. And as human welfare is increased, the ecological footprint also increase in more exponentially. So in case of the Indonesia, so the value we got, red line shows the footprint, and green line shows the biocapacity. And biocapacity is gradually decreasing since 1960s until now in Indonesia, which is mostly due to probably land development in the forested area. And red line going up, that means you have more industrial activities or economical activities. So according to these estimates, Indonesia already passed the turning point around year 2000, and your footprint is larger than the capacity per person almost 20 years ago. So that discrepancy is still expanding. So I show some other cases, like for example in Japan, in the middle upper graph, our ecological footprint has been decreasing since 1990s. This is due to very strong government policy to reduce the carbon emissions. But as well, biocapacity doesn't change so much because for example, our Japanese land cover, nearly 70% or 70% of forest land is covered by forest. We didn't change so much. So, but still have big gap between such footprint and the capacity. So in middle left, you see Malaysia. Malaysian case turning point came in early 1990s. Go to right, in Thailand case, that turning point, I mean that red more than the green, start late 1980s. So such turning point maybe stands for the balance between the footprint and capacity. But those social infrastructures development is very much important. So this is a case of India. So we need vehicles and commercial industrial activities and waste dumping, and those in the development stage, we need some sort of, in the production, some sort of waste. Yeah, but we need to consider the balance to the environment. So that this map shows a global road network. So most of global area is populated area is very much well developed. So that different area has different transportation development, mostly high abundance of high tollways or highways representing red colors. So as you will see, such road network is some kind of index to assess the footprints. So this is I take when last 2 years when I visited your country, then on all the overbridge I take some photos. Such situations is very much maybe usually the case for those who live in city in Indonesia. So that to assess the impacts of human eco-health, we did PM 2.5 measurement by the portable sensors and linked with satellite measurement. This is example we have done in Bandung City. But those air pollutions are one of the most important sources for the pollution is the transportation sector is the important factors. So this graph shows a Morris retrieval trend in the last 15 years. Red color shows the air pollutants has become worsening trend. And blue color shows air quality become clean and cleaner. So in Japan, we see blue color, even it is very much developed. As I show you in the footprint is decreasing, air pollution is improving. But in contrast to that, in India, some part of China, and most of in Java Island and Central Kalimantan, Indonesian cases, pollutants becoming worse and worse. So those pollutants level in the environment are in some relations, which is called the Kuznets curve. So the x-axis shows an indicator of economical indicator or human development indicator. Y-axis shows an environmental indicator. So in this case, I plotted over GDP per capita and NO2. So that as GDP goes up, those environmental indicator is going to be increased. So that means air pollutants level is going to worse and worse. But as some turning point comes, because government people maybe complain or government take necessary actions or the mitigation strategies. So if we compare that Kuznets curve historical plot of those the Kuznets curve is very much depends on the country. Some country learn a lot from previous examples. Then Kuznets curve is turning point comes earlier than the other country cases. So those evidence is very show us interesting finding of different situations. And remote sensing based measurement serve is to show the good enough evidence to work as an MRV, monitoring of reform validations. So, but this year is very special year, such COVID-19, no car in India, in this case, lockdown happened. Then one of my PhD students from India, his parents in India tell us that in the first time in the last 40 years, they can see the Mount Everest from his house. But this COVID-19 caused very much large reductions in case of NO2. But as you know, it rebounded already. Right? And nearly 30% of NO2 reduction were observed in March or April, end of dry season, but it has rebounded again right now. And such air pollutants cause physical damage to our lung, but also some mental problems. This is on Google search engine trend, what kind of keywords they search in the Google Earth. And we did a survey in Bangkok, in Thailand. Now, even the bottom graph shows air pollutants in Thailand is becoming better and better year by year, but people is more awareness for the air pollutant is becoming more serious, and they are worried about headache, depression, and psychological stress, and mental disorders. I think those kind of trend or mental problems has been caused. Also, it is enhanced by the COVID situations. But refer to public health, the independent our health is very much important. But public health issues is very much related with social issues. So this chart shows a public health slide since 1950s, which is almost equivalent to the land development has been started in most of Asian countries. Such start from polio or the Ebola or HIV or Zika virus in Malaysia, or maybe this year in COVID. But those public health sled is very much linked with our human activities, especially for the transportations. And for a long time, such neglected tropical diseases has been a big problem in tropical countries. And this graph shows evidence of public such diseases and passengers, number of passengers in the airplane. And as I show you in the roadmap, but also those airplane, development of airplane, and which will accelerate the spread of the diseases. And those diseases are originated from mostly those viruses originated from the soil. And soil development is related with wildlife and human conflict in Asian countries. And also denoted as land use land cover changes. Not only in Indonesia, but also most of those ASEAN countries. There's a lot of LULC changes. And so one of my PhD students from Thailand, she has investigated the impact of wild elephant conflict, which is very much induced by the rainfall drought in El Nino year, no rain, no food in the forest. Then they go inside, they go spread out to the neighboring agricultural land, which is impacted on the more interactions with the humans. Such not only wildlife, but also in Indonesian case or Malaysian case, you have such forest fire issues, and people go to the forest, and some people people said that is affected by such diseases. Right? And in case of Nipah virus infections, which happened almost 25 years ago, 22 years ago in Malaysia, which is related very much closely related with land cover.
Prof. Wataru, you have 3 minutes.
Yes, so I finish very soon. Oil palm plantations. And those interactions, especially bats become a carrier for that. And so such microbiological people and GIS remote sensing people work together in Malaysia to understand the mechanism, how those viruses are spread out. And in case of our country, Japan, right now, in Siberian regions, froze up, then they will bird migrates to China to Japan. Also, those patterns very much depends on the snow and frozen patterns in the permafrost regions. And such in COVID cases, bats is expected to be the biggest carrier. So that such integration with public health, terrestrial ecosystem, and land cover changes could be treated together. So now our university has started on such initiative within the university to work with remote sensing, environmental science, veterinary science, and medical science, and those different disciplines people work together. So this is it. Thank you very much for your attention. Thank you.
Thank you, Prof. Wataru, for your presentation. Your presentation is very interesting, detailed, and colorful. You're talking about geospatial technology towards one world, one health, and one earth. Once again, thank you. Committee, is there any question from audience? Pak Arifin, silakan Pak Arifin.
Thank you. Thank you. I would like to appreciate the presentations of Wataru-san. It is very comprehensive, and it gives us, I think, the community of the earth to see the picture, what is the well-being of the environment, health, environment and health, and also the decrease of the well-being of this planet. So I'm just wondering if your method can be proliferated through WHO or United Nations in such a way that people people or governments throughout this planet could get necessary alarms necessary for controlling their environment and so on and so forth. And do you think this can be driven by the international cooperation? I believe this should be a kind of international cooperation more than the national one, because the index is worldwide, correct? So thank you very much. This is what I'm thinking of.
Thank you very much for your valuable question. And Yes, actually, WHO and FAO, those necessary institutions work together in globally. But most of activities or the alliance between environment and veterinary science and medical science work together in US and European countries. In Europe and European countries, they work together, those scientists. But in focusing Asian countries, we do not have such initiatives. Medical science, maybe medical doctors work independently. Maybe environmental scientists, remote sensing science work maybe independently. So we need to integrate, need to take some initiative in Asian countries. So that was my message. And of course, international organizations are very much supportive to uh, to address and to enhance to work together in Asian countries in those different research fields. Thank you very much.
Thank you, Profesor Wataru. Terima kasih, Pak Arifin, atas diskusinya. We will go to the next presenter. The next presenter is Miss Amelia Savitri, STMA from Makassar. Miss Amelia has master degree from Remote Sensing and Geographic Information Science Research Group from ITB. She will present about unlocking the promise of space, a new era in geospatial information accessibility. Ms. Amelia, you have 20 minutes, 15 minutes to present your material, and 5 minutes for discussion. The screen is yours,
Sure.
Ms. Amelia.
Thank you. So let me just share my screen. Okay, can you see my screen? Hello? Okay,
Yes.
thanks. Okay, thank you. So good morning, everyone. Good afternoon. So my name is Amelia Shafitri. I'm a sales engineer from Maxar. I'm currently based in Asia Pacific headquarters in Singapore. So yeah, it's very unfortunate because this COVID-19 situation, everyone is working from home and not able to travel and meet in person. But anyway, I'm very happy that we can meet through this event, through Zoom, through online Zoom meeting. So here is my agenda for today. I would like to share about how Maxa provide a geospatial data in this new era of geospatial information accessibility. So I will talk about a very high resolution elevation data and some use case related disaster response, and continue to our online subscription called Secure Watch. And lastly, I would like to introduce a new technology from Maxa, which is a HD technology. So yeah, without further delay, let me just start my presentation for today. Okay, so I would like to begin with the introduction, who is the Maxar is. So maybe some of people here might know, or who doesn't know who is the Maxar technology is. A lot of people aware Maxar is a digital globe, so that is a partially correct. So Digital Globe has actually rebranded, become Maxar together with another 3 company, which is SSL, Digital Globe, and Radiant Solution. So now we are become a part of one Maxar. So basically, we are a company that manufactures satellite as well as the space infrastructures. Besides that, we also operate our constellation, and that is where Digital Globe comes in. And of course, we provide analytic services from Radiant Solution as well. So this year, we are very happy that we have a new additions that join Maxar. We have Vricon. So Vricon is the company who make high resolution global 3D elevation series. Well, if you look at Maxar has been doing over the year, we've been looking at Earth from the space for the past 20 years. So we are able to collect a historical data since Iconos satellite until today, the Worldview constellations. In upcoming years, we will have a new addition, which is Worldview Legion, which is will triple our capacity to collect the imageries. By having said that, we actually company that provide the most in-depth library in the markets. And we already serve so many vertical from mapping, disaster response to defense and intelligence. And thank you for all these constellation, we can actually produce so many products, including the high resolution elevation data, and unlock the inside information for the geospatial user. Talking about high resolution elevation data, so by utilizing our 100 petabyte archive imagery that back from 20 years ago, MEXA and Vricon able to create high resolution elevation datasets. So Vricon is built the true texture 3D model at 50 cm resolution globally, and this is of course is very high resolution for the global surface model created by satellite imagery. And this elevation dataset is able to produce high resolution 50 cm product without use any ground control points. So means you no need to send the physical person to the field to do the ground control point collections. And this product, this high elevation data have an accuracy of 3 meters spherical error 90. So means that 90% of this 3D model, not just X and Y, but in Z is in 3-meter accuracy. So how do the process works? So Vricon is built by utilizing multi-view technology and machine learning. So first of all, it start from a stack of imageries over the target area. So basically when you see here, the green color here is actually different ray traces of those image captures by satellites. Then after that, we do automated processing to do the image matching. By having different look angles, we can actually utilize the algorithm to do the semi-global matching using machine learning and cloud computing to tie each pixel of the each image within a stack. So the final product, it is a 3D texture 3D model. So after we have the 3D texture 3D model, we will then derive the derivative product such as digital terrain model, digital surface model, point cloud, classification layers. Then all of these derivative product is in 50 cm resolution and 3-meter absolute accuracy in all dimensions. So here is short of the derivative product that we offer to the geospatial market. We have digital terrain model, which is the bare earth. We have digital surface model, 3D surface model, 3D vectors, as well as a true auto. And you know, when you do all of this 3D, let's say you to do it to fire LiDAR or traditional stereo pair, sometimes it intend to be, it's very expensive, and you need to spend time to process the point cloud that collected. Most importantly, because this COVID-19, the challenge is to get the permit to fly over your desired area is very challenging. So that is why this Vricon 3D dataset products comes in to fill in the gaps. Okay, so now I want to explain why having high resolution 3D dataset is important. So in case of disaster planning and assessment, having 3D data can help users to do analysis, including perform flood planning analysis at different water level. Like, you know, city and regional administrator can build more accurate 3D models to improve disaster preparedness planning and response plans. And of course, and for the post-event, they can also actually utilize the digital terrain model to plan response effort and allocate the resources. So here is another sample for what you can use from the Vricon 3D data. So actually you can create a flood hazard risk modeling for simulation. So this is a simulation for in Davao, Philippines. So we use Vricon 3D data DSM, digital surface model plus true auto image. So this modeling actually allow us to calculate and predict the areas that may be affected with increased the water level. And this simulation also allow us to determine the submerged area. So when you see on the screen here, so I try to increase the water level. So when I increase the water level, as you can see on the left side here, I can see that, oh, this one is the lower, actually this area on the left side is actually the low ground area. And you see on the right side, this one is actually the road. So the road, some road might be flooded when I increase the water level. So this kind of information is actually very helpful and useful for user and communities to map the floodplains, where is the residential area, and of course to get the best road for rescue proposal and support flood resiliency efforts. Okay, now I want to share another use case. So now we are in the COVID-19, in this pandemic, now everyone depending on internet. Actually, these 3D surface models also help us to get better internet connections. In case of telecom industry, telecommunication, previously looking at 4G, now we are moving to 5G generation. And talking about IoT solution to have more robust type of communication, not only people talking to people, but maybe machine talking to machine. This 3D model actually help telecommunication provider to get more insight of the building height, line of sight, even the information vegetation. So then, the whole package of this 3D model enabling the type of telecommunication or operator create a better simulation. So then they know where to put the towers, so we can have a better internet connection and the machine can actually talk to the other machine. Anyone that using geospatial data is also aware that sources for the 3D data are expanding daily, not only from satellite imagery, but sources for 3D data can be collected from airplanes, drones, now even a car. So however, how can user ensure that what they're viewing is precisely located? So having this Vricon P3DR, which is a precision 3D registration, allow user to accurately geo-register your sensor data at anywhere. So this is actually software solution where we take a base foundation to register your data. So if you would like to register an image from satellite imagery or full motion video from drone or UAV and would like to register it in real time, you can do that in the P3DR. So it is not only high elevation data, user also can access to the pre and post event satellite imagery to our online platforms called SecureWatch. So SecureWatch is online based subscription that allows users instant access to the entire Maxa satellite image library and geospatial data. And this kind of type of subscription allow user to streaming and downloading to the most current and historical content via browser and as well as API. So this SecureWatch is also very easy to access. In this new normal where most everyone not able to go to the field or even fly area, we must go through the tedious and long process. This platform actually allow user to get access to the latest capture and to get more insight what is happening on the ground without them need to go to the fields. So not only the latest and recent imagery, user and all the responders, we can actually go to this platform and have access to the imagery from few years back, which is they can compare it what is changing in this area with the pre and post imagery. In case of natural disaster, having the pre and post data to understand what is changed, what is happening after the event happened is very important. Like back in 2018 in Sulawesi, Indonesia, there is tsunami that killing more than 400 people. So when crisis like this occurs, Maxa is actually committed to support the humanitarian community by providing critical and actionable information to assist the response efforts. So we are able to provide the pre and post imagery through this online platform SecureWatch. Then why pre and post imagery is crucial in disaster response? Having pre and post imagery will make more easier for user to understand what is impacted after the event happened. Like on the screen, on the left side, actually this is the imagery taken on August 17, 2018, and on the right side is actually imagery that taken on October 1st, 2018. So as you can see here on the right side, this is previous shoreline, when you see on the pre-imagery, is still there. Then now, after the tsunami happened, the shoreline now become, it's not there anymore, so it's gone. So this information become very critical for the user that responds to this event, and help disaster response teams quickly assess the damage and monitor changing ground condition from a safe distance. Another case that I would like to share in case of a natural disaster. So we in Indonesia happened a flood flash in July 16, 2020. So this in Sulawesi. So this is the imagery taken before the flash flood happened. As you can see here, the yellow color is actually the river line. And this is the imagery taken after the event happened. So as you can see here, this is the yellow line is the original river line, and now river line become widened. And it's not only that, by having the high resolution satellite imagery, user also can identify a lot of information from this imagery, like this, like on the white color box here. So previously here, in this area, maybe there is a park or the public space. So after the event, the flash flood happened, now the public space or park now is not there anymore. So this information is very useful for them, or for anyone that responds to this kind of event. And of course, you know, to do the manual surveying of the large areas of devastation can take days to complete. But with this pre and post satellite imagery, the first responders are able to make the most impact by efficiently and quickly mapping passable routes to deliver the critical services in a matter of hours. So it's not only pre and post imagery that you can see in this online SecureWatch platform. We also can utilize PCM. So PCM is stand for the persistent change monitoring. So this image is in the Hong Kong. So this one, Hong Kong Avenue Star Bridges. The PCM itself is the persistent change monitoring, where we deliver to the customer or user help to unload the highlight the location of the persistent change. So the persistent change monitoring become very beneficial for the user, especially in this situation, because this PCM and SecureWatch can become a tools to monitor the changes, to check whether is there any changes on the area without them need to go to the field. So as you can see on the screen here, we have PCM
Amelia,
saying,
you have 2 minutes, Mbak Amelia.
Okay, sure. So in this pictures, you can see here the yellow and orange colors. Actually, in 2018 there is a changes. So when I go back into my library in the SecureWatch, I can see that 2017 and 2018 there is a changes. So the bridges is already well constructed in this area. So the last topic I would like to share is the HD. So HD is the technology, is actually the proprietary algorithm owned by Mexa that intelligently designed to improve clarity of an image by increasing the number of pixels. So by using this HD technology, we are able to improve the clarity of an image and having the image well reconstructed details. So we just released a 15 cm HD last week, few weeks ago. So when you see on the screen here, we're having the 15 cm HD that produced by HD technology by utilizing 30 cm native resolutions. So here, this is the example that we produce from 50 cm to 30 cm HD, and we have the 30 cm native to the 15 cm HD. So when you see from the lower zoom level like this, we can tell that by applying HD to the native resolution makes the imagery more detailed and well reconstructed. Of course, the benefits for the applying HD, there's a lot of benefits, but the important thing is to the user that work a lot in remote sensing and artificial intelligence and machine learning, having HD will improve data and feature extraction. So as you can see here, when you utilize 15 cm HD, you can actually easily detect or quantify how much the car is there, how much is the tree is there, where is the road marking and extractor. So yeah, this will be my last slide. So improve this high definition technology, of course, will improve AI and ML object recognition. for the feature identification. You can basically doing the building extraction, oil tanks extraction, vegetation identification, count how many cars is there, even to count ships on the ocean, airplanes, wind turbine, and high voltage tower. So yeah, so all of this information become very useful, especially in terms of this disaster response. And you know, we can't stop disaster from the occurring, but with the right data, tools, and expertise, you can actually improve planning and expedite response to minimize the impact on the affected communities. So the data such as high resolution elevation dataset, online platform secure watch, and utilize HD for feature extraction, you can it can definitely help user to plan and understand, to have a better understand of what is happening on the land in case of disaster mitigation and regional resilience. So yeah, I know that it's only 20 minutes. If you would like to explore more about Mexa innovative capabilities, feel free to go to our website, which is mexa.com. We're also having a free sample. So if you want to know how 15 cm HD looks like, there is a free samples on our website. So feel free to go to this website. And if you have any question after this event, please feel free to email me or contact me via mobile. I'm more happy to answer all your questions. Okay, thank you and have a good day.
Hatur nuhun, Mbak
Sama-sama,
Amelia.
Pak.
Thank you, Mbak Amelia. Your brief and interesting presentation. Your presentation is about unlocking the promise of space, a new era in geospatial information accessibility. Is there any question from audience, committee? Pak Arifin, ada lagi? Terima kasih Pak Arifin. Pak Agustan siap-siap bertanya. Pak Arifin, silakan.
Thank you, Mbak Amelia, for the very nice presentations. I saw that among those captions, I saw that there are clouds still. So I'm just wondering also if your satellite troops still also to be improved by using radar or SAR or something like that. I'm just wondering first. And secondly, since you are doing a data information business in this case, I'm just wondering if there is somebody having a bunch of data, relevant data, with more accurate one. Do you think it can also be interchanged into your systems? And with, of course, with certain business modeling, of course. So I'm just wondering if there is such a possibility. Thank you.
Thank you, Bapak, for the question. So I hope my understanding is correct. Okay, so for the first question, how you can actually utilize the optical imagery to the SAR. So currently, Mexa, we do not have the SAR images, so we don't have any radar imagery. But absolutely, if let's say in terms of the application, you wanted to have an analysis, further analysis in case of, let's say, mining or something, so you can actually integrate our optical, even the elevation data, but from the optical imagery to together with the radar elevation data. So basically, yes, you can do that and collaborate the SAR data to optical data. So in case of, let's say, in the ocean, right, because our optical satellite didn't go through, our optical cannot go through clouds. You know, it's different like radar. Radar can penetrate the cloud. Meanwhile, our satellite, which is optical satellite, we cannot do penetrate clouds. But our satellite, which is can help the radar data to get unlocks features, the small features on the ground. You know, the radar data is black and white, so black and white. So our imagery is optical, which is there is a 16 bands multispectral, which is you can use to explore more what is actually happening on the ground. Yeah. For the second question, the second question is more to like if there is a customer who has the data, the more accurate data to be applied to our data. So in terms of elevation data like Rikon, so because Rikon is produced by automatic processing by machine learning, so without ground control points, we are able to do 3-meter accuracy. So we tried before to put in the customer or the user GCPs from outside our company, but the result is not much, so it's within 3-meter spherical error 90s. But if let's say customer have GCPs, then would like to have the more accurate auto-rectified satellite imagery, yes, you can do that. So we are able to receive any ground control points from outside to improve our accuracy in terms of satellite imageries.
Ya, terima kasih Pak Arifin. Thank you Mbak Amelia. If you have still question Pak Arifin, I have Mbak Amelia contact person.
Yes, Pak.
Okay, we still have 4 more presenter. So I will jump to the next presentation. Dr. Thomas Hige from Earth Observation Map, Germany. Dr. Thomas Hige is a managing director of the EOMAP headquarters in Germany, and has PhD degree in space science from Free University of Berlin. I hope Dr. Thomas Hige is still in our virtual room. So the
good morning. I'm here.
Yeah, the screen is yours.
Thank you very
Please.
much. So, good morning, Asia, and also welcome to all the colleagues here in Indonesia that I see already on the screen. Do you understand me well?
Yes, doctor.
So, yes, okay, good. Well, I hope that later you will have some questions to us and also my colleagues from Geotronics. So company Geotronics in Jakarta that is also on place in this conference at the virtual booth. So you have people here to ask about later if you have questions. And we addressed our talk today morning here in Germany on the satellite-based information services for aquatic systems, for aquatic and marine disaster mitigation and monitoring. So we address this to the topic of the conference as the company is doing a lot of projects worldwide directed exactly towards these applications. So just a few words about EOMAP. EOMAP is a company headquartered in Germany. I'm talking from right now, but we have affiliations in different continents, and also is a partner company Geotronic in Jakarta. We are doing mapping services, operational mapping services for governmental entities and industry in the aquatic and marine sector. That means mapping, but we're doing as well providing software, so enabling agencies with own software to process their own satellite data and deliver their own services, and also consultancies on that. And I will directly dive into the topic. So EOMAP is working in the aquatic field, as mentioned, in different applications. And if you see all these applications, of course, it is almost everywhere to reduce project risks, but it's also always to increase safety. For example, in navigation, when we deliver bathymetry on any scale, small and large scales, it is directly to increase safety. It is the same with coastal management. Usually we deliver here a lot of data, bathymetry, seafloor data, and for example, to support tsunami modeling for over-regional elevation models, land and water, seamless to have much better propagation of tsunami waves, or the same as to reduce environmental risks when large industries, which we are serving to, like the oil and gas companies, have to care about the environment, and this then already from the monitoring or from the baseline up to the direct monitoring. So to be more concrete, I will start with small-scale projects here in inland waters. So EMAP is serving to a number of clients. For example, in Brazil, you might remember one of the largest disasters in Brazil a few years ago at the Rio Doce, where we contributed then from that time with water quality data about the water quality in the river Rio Doce after this disaster, to show what happened exactly, but also to follow up on the impact of this disaster. Since that time, we are working with a large company, Lactec in Brazil, who as well uses the software. There are also small-scale disasters that need to be prevented. So, for example, the impact of the climate change. So we had 2 years ago an extremely hot summer here in Germany with a big impact on cyanobacteria blooms, which is a topic in many countries. So monitoring whole Germany with cyanobacteria blooms, all small-scale lakes. And this is something that we do since that time then regularly as well for different states in Germany. For example, Rheinland-Pfalz uses operational monitoring since that time then from EOMAP to control bathing safety with respect to the cyanobacteria. There are some further applications. I will dive just into few. Hydropower is always a topic of disaster prevention, but also of reducing the risks when you build and plan such costly environments like hydropower dams. You see here one example of a client in Africa, so the Mozambique dam, where we deliver daily data, also in an operational mode and inform here the operator with much more actual information. And how does this look like? You see here a plot of time series for one point here in this basin, where you see a lot of satellite observations, many more that you could observe only in situ. This is this year and most actual. That means having this data on hand reduces risks in running such environments and provides you actual information which you otherwise would not have on hand. On the small scale, as I mentioned, for the state Rheinland-Pfalz here in Germany, we deliver as well online with an online application, but also with reports to the water quality status of even small lakes, as you see here, very small lakes. So a number of lakes over this country which are delivered since approximately 1 year with chlorophyll, cyanobacteria, sensitive temperature, support also the decision-making processes when they need to go to the lake in order to take further probes and also inform the people on place. It's delivered also through a web portal, so very easy for the country to follow up on these harmful blooms. Next application, to give a further taste, is of course coastal applications. Sorry, here, no, just a second. Coastal applications is a big topic because we have a number of risks here in the coastal applications in order to reduce risks for navigation and safety. The first one I mentioned is tsunami modeling. So on the large scale, having actual shallow water bathymetry is very relevant for the tsunami propagation, for the propagation of the tsunami waves. So we delivered in Asia shallow water maps for tsunami modeling as well on large scale. For example, here you see on the right hand side in the Middle East, seamless land water models with the most relevant areas, the shallow water areas, then filled up by actual satellite data measurements. And it's the same then on the left-hand side this is more for industrial projects, for planning, having seamless land, shallow water, deep water maps. On the safety side directly is delivering such data in a higher resolution for hydrographical authorities in order to increase navigation safety, because many charts are outdated worldwide, or well, still need to fill with much more actual water depth information. This example here for New Zealand LINS covering an area of 400,000 square kilometer and high resolution in a combination between LiDAR and acoustic surveys delivered by AGERS survey, satellite data, which contributed to the largest part of the area by far here, is one modern way. And you see these satellite data are nowadays then in those charts, reducing risk for the daily life of navigation. Same for Indonesia, where Pushidrosel is using our satellite-based software to produce on their own. And even one step before, to identify shoals is a big topic, and you will see in the next 1-2 weeks that EUMAP is publishing here very large areas, continent on a continental scale, a shoal database to directly identify where you have risks which are not in charts. You see a lot of accidents still happen because the shoals are partly located on the wrong position, partly then not at all in these cards. So we support here to increase safety with such a shoal database. On the smaller scale, shoreline delineation to monitor where the shoreline changes due to construction and also all the processes in the ocean. We delivered here for Gaza and in the Mediterranean, and support here the authorities with actual information on a portal. I think it might be even freely online portal, EOClinic portal, which you see here, with information on the currents in the ocean, on the morphologic changes of the coastline, to really understand what is going on over decades even. So EUMAP uses a lot of different satellite resources here to have the most actual and most temporally dense data on hand. Coming to even smaller scales, so for different maritime industries, like in this case for Van Oort, an international dredging company, we regularly deliver data frequently for project planning, before they start sending their big ships to those areas to navigate better, but as well then to monitor changes, morphologic changes on those environments that they are working on both bathymetry, seafloor, environmental parameters. Increasingly, clients and agencies understand better to use these satellite-based information streams for their demand, but also increasingly they intend to have an own production in-house, at least the larger ones, as Pushidrosel in Indonesia and other hydrographic offices, but as well environmental institutions. So EUMAP provides for such clients software. It can be a desktop software, but especially as well web applications. There's no requirement to install software, and there's also no requirement to download satellite images, because this analytics software is already directly connected to the satellite data archives. And that's so that means you can even run such processes from the boat. Of course, you need just internet connectivity to the browser to run these processes. There are different tools. I will not go too much in detail here, and there are also databases that we provide. There are tools to access such information, to ingest information, visualize. So these are the EOAP web applications, and we will launch a new EO portal soon, which have a very convenient access to a lot of information, and to integrate this better into the different customized sections. So we have a dedicated portal here now for the hydropower section is being built up to the same. We will launch soon for the environmental agencies with the reporting demand. You see the EOClinic example here for the coastal monitoring, the desktop software here for bathymetry, and the same on the analytics side on the web application to just through a web browser to steer your production on required water quality or bathymetry data through such a portal very convenient. I hope you have some questions about that. Yeah, final words about EOMAP. So it's a company now 15 years, more than 15 years old, a spin-off from the German Aerospace Center here in Germany, but offices then in other continents as well. Yeah, we are delivering to a lot of entities, and I welcome you to come back to my colleagues here, so Geotronics in the booth of this conference, and also to come back to us with further questions anytime. Questions?
Questions from audience? Pak Agustan, ada yang mau ditanya? Mbak Marina, ada yang mau ditanya? Audience, committee, is there any question from floor? You are not like Dr. Hige. There is no question.
Yeah, okay, it will happen another time, but I'm looking forward then to see the conference ongoing.
Thank you, Dr. Thomas. We will jump to the next speaker. The next speaker is Dr. Irwan Meliano. Pak Irwan, are you already in our filter room? Okay, he's still not there. Doctor, okay, we will go to Dr. Damien Colson from EO Factory, Belgium, because
yes,
Dr.
hello.
Irwan, okay. Okay, your screen, Dr. Damien, please.
Okay. Okay, hi everyone. So I'm Damien Closson from Belgium, but I'm presenting EO Factory, which is a solution developed by SkyMap Global, a company based in Singapore and in India and Saudi and many Southeast Asia countries. So the outline of this talk is as follows. So a few words about the solution named EO Factory, and some points related to the image selection, download, process, display, compare different kind of manipulation of satellite image, such as mosaic creation and land use, land cover classification with machine learning. And then a few words of conclusion. So EO Factory has been developed by SkyMap Global for about 1 year now. So it's a new product, young product. It's a solution available on the web, and it targets to the use of remote sensing by a wide community, and not only the community of the experts in remote sensing. So basically, the platform allow a user to download satellite image or upload his own satellite image, process without specific expertise, knowledge, such as, for example, atmospheric correction for optical image or pre-processing radar data. Then once the image has been processed, they can be analyzed or transformed until information extraction, and then prepare reports. So basically, when you enter EO Factory, first you arrive to the desktop, the workspace. You create workspace like here. So there are plenty of workspace, different type of project. And in each project, you can load a certain number of image and you can process and share and store the data. So the workspace can be private or shared with different people just by using their email. You can also give some properties, access, and so on. And all data, as you can see, there are big projects or small projects, all data and algorithms are stored in the web. So in fact, you just need a simple laptop and an internet connection to do your job. So this is, when you enter the workspace, this is the place where you can put satellite image you just have processed. So on the left side, you see there are different type of buttons. So imagery is the place where you put your imagery. You can share your image also with people just by using email address. You can, we will see a bit later, build models based on artificial intelligence. So here we are talking about a convolutional neural network algorithm. You can create maps. You can follow the task. So when you are doing, for example, classification, it can take some hours, even days. So you can monitor the task, and you can manipulate the results of your work, create data sets or load data sets, and so on. Here is an example of satellite Sentinel-1 radar image that has been processed and customized in order to provide some colors, making the radar image much more attractive than the simple usual grayscale image. And you can compare this image with different type of image like a planet data or a Bing map. What is interesting using this EO Factory solution is that very basic but very important tools are present, such as the comparison between two contemporary observation, one done with optical and the other done by radar. Of course, we know that optical images are easier to interpret because they are done in, for example, here in natural colors, and very intuitively, because it's the world we are living, we understand that the white color corresponds to the clouds, green color to the vegetation, brown color to the ground. In radar, we have also colors, but it's not intuitive at all. So we need to match the two. And just by comparing the tools, we can do it like that. A very interesting tool. There are plenty of tools. I cannot show all of them in just 15 minutes, but an interesting tool is named Mosaic. So it allows a user to create a mosaic of large areas. So if you want, for example, targets the change detection of the forest over Kalimantan, you have to download, process around 20-25 images, and you have to process radar image if you want to avoid radar and you want to you target a specific moment of the year, for example the rainy season. You want to know exactly what's happened at that period, so you have to download 2 times stack of 20-25 images. And then you have to create mosaics and then compare mosaics. So this kind of operation is needs a lot of computation, and everything can be done with EO Factory without a big hard disk or storage place and so on. So this is the result, and it is quite interesting to see that the raw data we download, from example from the Sentinel data up here, are also have some issue as highlighted by the ellipse. But you can see that we have colors. We are talking about radar, but we have colors. We have plenty of information, and we can also customize the resolution. So here I process the data at 50-meter resolution, but the native resolution is 10 meters. So depending the type of job, we can play also with the resolution. Now, classification. So how to turn this mosaic with plenty of colors into classes having a meaning. So to do that, we have to train a model to do a classification. So the first thing is to define an area with plenty of colors, and colors meaning having, of course, a specific label. So for that, we drew just a rectangle somewhere in the image. Then we add some layers, schematic layers, like water, for example, and we digitize on the screen a certain number of pixels corresponding to that classes. And once it is done, we run and we create like that a model. The technology behind is convolutional neural network. So what is interesting here is that without having any knowledge, any background, of course, to play with satellite image, you need a scientific background. But the goal really is to simplify the number of operations someone has to do. Normally, the researcher in academy are using plenty of software, freeware, or commercial on-the-shelf software. Here, everything is included inside this solution. So once we are training the model, we can follow the process. And once we have created this model, of course, the creation of a model can take some time, some hours for the very simple, or some days. You can create models and you can share with the community. So that you avoid to duplicate a large number of times the same type of manipulation. And you can apply, of course, over the same type of image. And so what you have to do just after that is to load for example, your mosaic here. Load the model you have created and launch this model to create that kind of classes, each color having a specific meaning. For example, the purple color correspond to bar soil, for example, and the green, yellow is different type of vegetation. This can be validated by using the optical image we have seen before. So, in conclusion, what we have seen with EO Factory is that we can very easily select image, optical or radar. We can download and pre-process the radar, the radar and optical image. Everything is stored in the cloud, so you do not need a workstation or multiple hard disk. You do not need to play also with multiple license. We can compare optical radar image. We can create stacks and create also multi-temporal image. We can create mosaics. We can do also classification, which is one of the most difficult exercise in remote sensing. We can share all those information, capture image, and export everything in order to create some report. So if you are interested by testing this solution, you just have to contact the marketing. As you can see, marketing at eofactory.ai, or you can contact me through my credential in this meeting. So if you have questions, I'm ready to answer.
Thank you, Dr. Damien, for your presentation. Dr. Damien Colson is from EO Factory, Belgium. Committee, is there any question for Dr. Damien from audience? Mbak Marina mau bertanya? Yeah, if there any question later, Dr. Damien, we will conclude that question and I'll send you information about that question later. Right now, there is no question for you.
Okay.
Okay, thank you, Dr. Damien. Mati lagi ininya. Nggak mau. Okay, our next presenter is Dr. Irawan Meliano. Sorry. Our next presenter is Dr. Irwan Meilano from ITB. I'm sorry. Kacamatanya perlu diganti. Dr. Irwan is Lektor Kepala, Associate Professor from Geodesy Research Division, Faculty of Earth Science and Technology, Program Studi Geodesy di Bandung. Has master degree from Nagoya University in Earth Science. Also has doctor degree from the same university in the same in Earth Science, and already got postdoctoral also in Nagoya University. Dr. Irwan will present about lesson learned from the Palu earthquake, an Earth Science perspective. Pak Irwan, the screen is yours.
Okay, good afternoon, everyone, and thank you for the chairman for the introductions, and also thank you for inviting me to this very important conference. Today, I'd like to share my experience after doing 2-year research in Palu, and this is collaborative research among 4 universities, not only ITB, but also we do research together with Gajah Mada University, UNAIR, and also Institute Pertanian Bogor. So we did several times field survey in Palu, and today we would like to share our experience based on the result we obtained from the field survey. So my discussion today will cover not only the science part of the earthquake, but also a little bit about social aspect of the earthquakes. This is my conclusion. So we found that in Palu, we still have problems in terms of the uncertainty in earthquake models. And this kind of problems makes the process of recovery and also build back better in Palu takes longer than we expected. We found out there is difference in perceptions from the expert and the community and also the local government as well. And also we found another problem, the uncertainty in tsunami generations. So there are several studies suggest that the tsunami generated by, for example, the landslide and also by vertical motions or the super shear of the structurally fault motions. And the last topic is about up to now, we still don't have an adequate multi-hazard risk models. And I will explain in detail those three different topics for the next 15 minutes. In this slide, I'd like to show you the damage to associated with the earthquakes. So the blue dots show the area that we visit. Actually, we visit almost 400 sites, and not only visit and see the buildings, but we also do the interview with the peoples. So the blue square show the locations with heavily damaged, while the green and the purple show the locations, and not the green, the yellow and the purple show the locations with medium damage, and the green show the locations with minor damage, slightly damaged regions. And you can see on the left side, on the right side, the photos of the buildings that collapse either by the earthquakes, tsunami, or combinations earthquake and tsunami, and also liquefactions. And based on our survey, we found out that 40% of buildings in Palu heavily damaged. About 29% medium damage. You can see the photos here. It's a type of medium damaged buildings, and 23% slightly damaged, and only 8% with no damage. So only very small portions of buildings survives after the disaster. And then not only the field survey, but we also doing deep learning analysis just to see the effect of the tsunami to the building. And this one has been presented yesterday. I just want to share you the result of the questionnaire, the discussion with the local people. We asked them very simple questions. This one of the example of the questions. Before September 2018, before the earthquake and tsunami, did you ever know if an earthquake, tsunami, and destructive liquefactions could occur in Palu? So the reason why we pose these questions to the people, we just want to understand whether the local peoples already understand that sometime in the futures, with certain percentage of probability, they will experience the disaster. And as we expected, the answer from of the community, 2% said yes. It means they already understand that they live in the disaster-prone regions. And then 2% said yes, and they said that they learned from the media. Another 2% said yes, and they said they learned from school. 6% said yes, and they said they learn by they hear the stories of past disaster events. So the fathers or the mothers or the elderly told them that there was a disaster in the past. And 16% yes, because they already experienced the same disaster in the past. And then the difference between the blue colors, yellows, the blue colors is the earthquakes, the yellow is tsunami, and the black one is the liquefactions. But 90% said no. So 90% said they never expect that disaster would happen in the regions for the liquefactions. And 80% said no for tsunami, and 71% said no. So in average, about 80% of the community, they don't expect that they will stay in the disaster-prone regions. But if we compare this finding with the fact that this area, the Palu-Koro Fault, is one of the well-studied area in terms of the earthquake cycles. The first paper already published since 1977, and since then, at least 5 papers already published about this active fault. For example, from the GPS, there are several papers that already estimated that the slip rate or the accumulated slip rate of this fault is about 40 millimeters per year. And also the same numbers come from geological observations, with slightly lower numbers, 35 millimeters per year. But actually, the scientists already understand about the cycle of the earthquake in this area, and eventually they already calculated the slip deficit. They already calculated the moment accumulations, and even they already put this one into the National Seismic Hazard Map and already become national standard SNI for the earthquakes. SNI numbers 17. This earthquake is already become the national standard. So basically, the researchers already published, and also it's already become the national standard. But based on our interview with the local people, we found out 80% of them, the local people, they don't understand. They are living in the disaster-prone area. It's a kind of gap. But in order to answer the next questions, how about the tsunamis? It is very hard to answer why we have the strikes, why we have the tsunami, although the mechanism of the earthquake is the strike slip. And one paper published last year by Sequet and et al. She found out that the reason why we have tsunami because the Palu earthquake is not a normal earthquake in terms of the rupture velocity. This is the kind of earthquakes that produce very fast ruptures. That's the reason why most of the scientists said that this is super shear earthquakes. The earthquake that produce rupture velocity faster than 4 kilometers per second. The normal earthquakes, for example, Yogyakarta earthquakes, or most of the subduction zone earthquakes in Indonesia, the rupture velocity is about 2 to 3 kilometers per second. So it's 2 times faster than normal earthquakes. And these fast ruptures may generate not only a horizontal component, but also vertical components ruptures may generate the tsunami. And also, a few weeks after the earthquakes, we did a survey and we found out very clear left lateral motions. We found more than 5 millimeters offset. This is, for example, very clear left lateral offset in the south of Palu. And also from the satellite image, satellite Sentinel-2 also detect this clear offsets. And this is another example of the strike slip motions. This is the data that we got on October 10th, a few weeks after the earthquakes. And also not only the horizontal component, as I explained earlier, we also found the evidence of the vertical offset. And recently we processed, a few months ago, we processed the continuous GPS data. So not only from offset from the field survey, but we also found the co-seismic offset from the continuous GPS observation. This is one of the continuous GPS stations maintained by BIG, the Geospatial Agency of Indonesia. And from this time series, the first figure show the EW component, east-west component, and the second figure show the north-south components, while the third figure show the vertical components. And you can see slightly offset before the years 2019. The magnitude of the offset is very small, but because the distance of the station is quite far from the epicenter, it's about 200 kilometers to the north from the epicenters, but still we can see quite clear co-seismic offset. And this is another station, the one in the south, and again, we can clearly see the co-seismic offset from these stations. This is station located in Palopo. And this is the complete figure of the co-seismic displacement from this co-seismic map. From the far field continuous GPS stations, we can clearly see the patterns of the left lateral motions. And it is very interesting to see that the station, for example, the one in the north, Toli-Toli, which is located almost the same distance with Palopo, the one in the south, about 200 kilometers, but the magnitude of displacement in Toli-Toli is much bigger compared to the Palopo. And it suggests it become a very clear indications of the heterogeneity in slip during the earthquakes. And this heterogeneity probably also produce different vertical motions associated with the tsunami. And furthermore, we estimate the magnitude from the GPS. We do the rapid estimations of magnitude from GPS data. So the way we obtain this magnitude, we calculate our GPS by using every epoch solution, so not the daily solution. So the x-axis is time in second from the earthquakes, not in. So we usually, when we process the GPS data, we obtain one solution per day, but to estimate the magnitude, we calculate the GPS displacement every second. This one in the this result is under process. It will be published soon, and the first author is Susilo from BIG. And by using this data, you can see the red dots below, and so we estimate the magnitude. I'm sorry, the blue dots. The blue dot is the estimated magnitude from the GPS, while the yellow dot shows the estimate of magnitude from the seismic as a comparison. So you can see that GPS may estimate magnitudes quite fast, and this has become additional informations for the magnitude estimation. And another informations about the tsunamis is we obtain from the satellite images. The figures in the right side show the vertical motions, and it is very interesting to see that in the Palu Bay, from the satellite images, unfortunately, we cannot get this kind of result from the GPS data since we don't have a GPS station very near to the epicenters. But the INSAR data give us a very good indications of the downward motions. So not the uplift, but the negative vertical motions. And this downward can also may produce the tsunamis. And we tried to model the tsunami. So our team members, Windu Pranata et al., tried to model the tsunami based on the strike slip motions. and basically, it is very hard to obtain tsunami models higher than 1 meters by using the strike slip motion only. So we need another source, and probably the additional source from of the tsunamis came from the landslides. So the landslide might explain an additional tsunami, or maybe the landslide, the tsunami from the landslides appears earlier or faster than the tsunamis come from the strike slip motions of the fault. And this is for example, another published papers. They try to compare the deformations, Palu Bay deformations by using the vertical motions and combinations vertical with the horizontal motions. But eventually, if you want to if we compare the tsunami obtained from deformations only of the Palu Bay with the observations of the tsunami, same models of the tsunami is lower compared to the observations, because one of the explanation is we have another source of the tsunami, which is come from the landslide. And another issue, another challenge that we learned from these earthquakes, we need a multi-hazard risk models. And Palu is a good area to build these multi-hazard models, since we have several type of
Pak Irwan, 2 menit lagi Pak Irwan.
Baik Pak. Since we have an evidence that several houses damaged not only by tsunami, but also some area damaged by earthquake plus tsunami, some area damaged by earthquakes, some area damaged by earthquake plus liquefations, and some houses damaged by liquefaction only. So we need a multi-hazard model that may explain the risks that combine different kind of hazards. And this is the conclusions. And so the first one is we found the uncertainty in earthquake models, and also different perspective from expert and the community. And also we found the uncertainty in tsunami generations. Some published papers try to add to put additional source, this landslide. And the last one is, this is more to discussions. We need to have a multi-hazard risk model, because the kind of disaster that occur in Palu probably might happen in another area. So, and this is my last slide, the discussions. And we need to solve this uncertainty And by solving this uncertainty, we can make our recovery faster. In the case of Palu, we have lack of observational data. We have a lack of scientific evidence. Since we have lack data and lack of scientific evidence, so we try to be very conservative. So during the reconstruction, for example, we put all the map in Palu area become the yellow one, and it makes the reconstruction process become very difficult because it's very hard to find a good and safe area for reconstruction. Thank you for your kind attention.
May Lano. Thank you, Pak Irwan. Your presentation is about lesson learned from the Palu earthquake and earth science perspective. There is one question from Slido from Elsum. I will read the question. From lesson learned from Palu earthquake, what should people do where they live in the active fault? A sample in Lembang fault where there area dense population. Silakan Pak Irwan.
Terima kasih. This is very good questions, and then because the lesson from that we can learn from the Palu area, the challenge is not only for the people, but also this is the challenge for the scientists as well. So the first step is the scientists needs to explain the hazard better. So we need to have a better information about the hazard in that area. For example, if you mention the Lembang fault, then we need to really understand the return periods of the fault. We really need to understand the slip rate of the fault. And then after that, we really need to understand the hazard. And after that, we have to make a detailed information regarding the risk. So we need to start from the source models, and after that, we need to calculate the risk. And after we have a detailed information about the risk, then we may discuss the risk with the community. And then together with the community and also with the local governments, we have to come up with the risk reduction plans. We need to have a good methodology for disaster risk reductions in detail. But the first step is to have a good information related with the hazard. And I think that's one of the problems in Palu. We don't have a very detailed information of the multi-hazard risk map before the disaster. We never discuss about the multi-hazard risk with the community before the disaster. I think that's a very important lesson that we can learn from the Palu earthquakes. Thank you, Pak.
Hatur nuhun, Pak Irwan. Pak Agustan, maybe. Okay, maybe Mr. Nurdin from Earth Observation Singapore still in the virtual room. Any question, Pak Nurdin? Okay, Mr. Nurdin is not in the virtual room anymore. Pak Agustan?
Thank you, Mr. Chairman, Pak Heri Satmono. Thank you, Pak Irwan, for your good presentation. I'm wondering about your slide regarding the percentage of the community. The knowledge of the liquefaction is almost zero, as you present. So I think it's very challenging because liquefaction is not popular before the Palu earthquake. But however, maybe we can find some location that have any potential for liquefaction. So what is the best solution or the best effort to educate or to communicate to the people about this kind of the hazard? the liquefaction. For example, in Aceh tradition, we have a song or a literature about the tsunami. However, the liquefaction, we still not find the local language or idiom or something. So what do you think about this kind of the hazard, the liquefaction, Pak Irwan?
Yes, thank you, Pak Agustan. You pointed out very important issue regarding the liquefaction. Yeah, after we finished our field survey, we were very surprised to know that only 5% of the people understand about liquefactions, and we elaborate more how they get the informations of the liquefactions, and most of them they got the stories from the past disaster. They hear the stories from the elderly about the past disaster. So the liquefactions in Palu, maybe I'm not the expert in liquefactions, but this kind of liquefaction probably already happens in the past. But we don't have a good record about these liquefactions. But this is the very challenge to for us as a scientist. So to answer your questions, the first step is we as a scientist need to clarify the source of the liquefactions. Some published papers said that this is associated with, for example, the canal system and so on, and type of the soils and the groundwater system, and so on. But as a scientist, first we need to clarify the source of the liquefactions, and then and after that, together with the community, we need to find the solutions for that. So we need to produce the community-based disaster risk reductions. This is, in terms of the timing, this is a very good period because I mean, it is only 2 years after the disaster, and they still keep the memory of the liquefactions up to now. And another strategy is we need to establish a good and respected center for the liquefactions in Palu, and this is one way to keep the knowledge, to keep the history, and with the hope that the future generations will understand they live in the liquefactions disaster prone area. I hope I answer your question, Pak Agustan.
Terima kasih Pak Irwan. Thank you Pak Irwan for your brief and detailed answer. Applause to Pak Irwan once again. Alhamdulillah, now we arrive to the last presenter. My colleagues, Dr. Marina will present about IEEE Ocean Engineering and IEEE Technology. Dr. Marina has several master degree, one from San Diego State University, one from Avignon University, France, and has doctoral degree from University of Texas, Austin. Mbak Marina, you have 2 minutes. Oh, sorry, you have 5 minutes. You have 10 minutes to present your IEEE Ocean Engineering and IEEE Technology. Yours.
Thank you, Mr. Moderator. Okay, the last but not least presentation. So these 2 days we are actively conducting a program of IEEE program, and Indonesia actually has been active in IEEE program for 30 years. And as a maritime nation, ocean engineering is an important aspect. And in addition, technology and engineering management is closely linked to ocean engineering activities. For that reason, we are submitting a petition to form a joint chapter of IEEE Ocean Engineering Society and Technology and Engineering Management Society. We think this will fulfill the need to engage academicians, professionals, and businesses involved in ocean technology, as well as engineering management. Okay. Furthermore, this joint chapter may promote various aspects of ocean engineering and increase interest in ocean engineering. For that, I would like to show you the website of Ocean Engineering Society. If the committee may show the website, the Ocean Engineering Society website. Okay, so you can see the website here, and from what I read, this society was formed in 1968, so it has been about 60 years ago. From the menu of About Us, you can see the aspects or sciences that are of interest in this society. For example, science, engineering, technology that address research, development, and operations pertaining all bodies of water. Okay. If we can look at the publication, for example, the Earth Design publication, Earth Design, that's containing all the various interesting. Okay, Earth Design publication, Earth Design. That's containing the various interesting topics in ocean engineering and ocean sciences. And other than that, of course, they have also a journal, which is called the Journal of Oceanic Engineering. So next, the joint chapter that we are submitting, the second one is called the IEEE Technology and Engineering Management Society. If you can show the website. Yep. Okay. Yeah, again, here is the website. And if we can move to the About Us, it will show the field of interest of this society, which is, if you can scroll down a little bit. So it's called on the management sciences and practices required for defining, implementing, and managing engineering and technology. So we feel that by forming this joint chapter, Oceanic Engineering Society and Technology and Engineering Management Society, the chapter will attract new IEEE members and create more collaborations opportunities among the professionals and academicians. So the newly formed joint chapter, hopefully together to form through seminars on ocean technology and ocean engineering. And also we would like to conduct field trips when the condition permits to do this. Okay. So for those who are interested in ocean sciences, ocean technology, and ocean engineering, we'd like to invite you to join the chapter. Thank you.
Terima kasih Mbak Marina, thank you Mbak Marina. Before we conclude this morning session, please share your face, all participant, all committee, all audience. We have photo session now. Please share your face. Pak Arifin, monggo ke depan. Mbak, boleh berdiri. Panitia siap-siap. Berapa kali take? 4 kali take. Kita akan 4 kali take. Mohon dihitung panitia.
Pembicaranya siapa lagi tadi?
Udah selesai. Pembicaranya Damia.
Thomas Iger.
Thomas, Amelia.
Benar.
Itu dia udah. Amalia. Ya.
Irwan.
Pak Irwan.
Ya ini kan udah ada tulis sama aja.
Oke, 1, 2, 3.
Kamar yang mana?
Ini dulu ya, satu dulu ya nih.
Iya.
Bu Buti agak. Oke. Bu Buti aja berarti.
Buti. Masuk ke kanan.
Oke, 1, 2, 3. S1. Terus yang apa?
Berbicara.
Galeri aja loh. Ya udah. Kasih galeri aja loh.
Iya. Masuk gitu. Jangan juga.
Jangan ya.
Jangan apa?
1, 2, 3.
Gak kelihatan juga ini kalau senyum bentukan mata.
Iya.
Tapi naruhnya senyum ya Pak ya.
Slide 2. Ya, nggak ada fotonya. 1, 2, 3.
Iya, otomatis senyum ya, padahal nggak kelihatan. Kalau senyumnya lebar.
Siapa lagi mau masukin siapa lagi?
Matanya tanya beda.
Ada Pak Yudi tuh udah.
Ini udah ada.
Oh iya Pak Yudi.
Oke, ya 1, 2, 3. Siapa lagi yang perlu dimasukin?
Terima kasih, komite. We now conclude the morning session. We already discussed about A to Z, about role of information geospatial professional in new era. Thank you for your attention. Thank you for all speakers. Thank you for all participants with your passion still in the virtual room till now. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih. Time komite.
Thank you so much, Dr. Heri Satmono, as our moderator for plenary session in second day of conference. And I would like to thank you for all the speakers and all the participants that join us in Zoom meeting. I hope we can learn so many things from our speakers. And I would like to inform you that our presentation will be start at 13:30 Eastern Indonesia time. So you have around 1 hour, 45 minutes, to have break time to do praying or something else. In the name of committee, I would like to say thank you, and the plenary session is officially done. Thank you. And our Zoom is still on during the break time, so if you still want to join, you can still in the room or just leave and you can join in the same room meeting. Thank you so much to our speakers. Thank you.
Thank you. Bye.
Thank you. Goodbye. See you next time. To our speakers. Thank you so much.
Thanks.
See ya. Yes.
Udah langsung masukin tayangan itu ya?
Yep.
At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. At Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world. Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communication satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world.
for all the participants. Yes, we would like to thank you to all the presenters and all of the participants. Now we are still counting to the best prepare and to this conference, and we would like to ask to all the participants that still in the Zoom meeting to wait for this moment, because we have to wait our organizing committee to announce the best paper later. Yes. Okay. Maybe I want to ask our this event. Mbak Pio, can you step beside me? How you feel to this conference and during this event? How do you feel right now? Hey, social distancing. Okay. On behalf of the committee event, I would like to thank you all, to all the committee and to all the audience participants, presenters, and speakers for your support. So it will not be happen without your help and without your help. That's all. And again, I will Master of Ceremony. Thank you. So short but effectively. Thank you so much for Mbak Pio for mengepalai. So what's the English of mengepalai? So how about the announcement, sir? Is it ready? Yes? Okay. And now I will let Mr. Agustan to announce the best paper.
Okay, thank you, Mbak Zilda. So on behalf of the committee, we already thinking very hard to decide to choose. Should we choose ya, Pak Oni ya? One from the 36 accepted papers. And then actually it's very hard because the quality of the papers is quite above the average and very good. So we must edit some parameters. So we would like to assess all the presentation in these 2 days, last 2 days. So we also consider how the presenters convey their message and how the presenters deliver their research, discuss into the audience and so on. So based on the committee analysis from Bu Marina, please give applause. Camera, white lens, white lens. Oni, and also all teams here with the moderators from all the audience also. So we would like to announce the winners of the Indroyono Award for AGERS 2020 and Pertemuan Ilmiah Tahunan MAPIN ke-26 tahun 2020 jatuh kepada nomor paper 157. Oh, in English, I'm sorry. So the ID for the papers is 15706. It's the same, yeah, all the papers. 706 is the same. 9 also the same. The last 4 digit is 4134. Congratulations. The title is Sedimentation Analysis Towards the Changes of the Mangrove Area Using Multi-Temporal Remote Sensing Technology, Case Study in Gresik Regency. The authors is, I think I know this name, Bangun Sukoyo, Nurwatik, Nova Nurul Anissa from Institut Teknologi 10 November, Surabaya. Congratulations. So please, where is the 10 millions? Show the 10 millions. Where is my money? Show me my money. Ah. So we would like Bu Rika. Bu Rika is in the waiting room or in the Zoom. Rika Hernawati, the treasures of MAPIN that already get the money from Professor Indroyono. Show your face. Don't run away. Bu Rika, so the winners, please contact to Bu Rika to provide your account number.
Okay, thank you, Pak Agustan. I will contact the author, Pak Bangun Sukojo, and then I will ask him to write her account. And yeah, Pak Bangun, just wait my information. Thank you.
Okay, thank you very much, Bu Rika. Congratulations all the authors and all of us, the authors that already working very hard to provide the best paper, your best effort to disseminate your research during the AGERS 2020. So on behalf of our committee, we would like to waiting for your next step to provide the final manuscript to help us to submit it in the IEEE Explore. So it's very tough, it's very difficult, and need continuously work, yeah, especially by checking your grammar, writing style, error checking, and then see you next year, yeah. Okay, thank you. Pak Odi, is there any in Jakarta? Okay, so see you next year in the AGERS 2021, inshallah. Yeah, okay. Thank you very much, Panitia. Bu Fio, please give applause to Bu Fio. Kamera, 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 kamera. We would like to introduce all the committee here that working very hard. The first, the chair of the Yolenta Marpau, and then Ibu Zilda, our MC, Master of Ceremony, Ibu Evi. Kamera, sorot ke sana. Ah, ke sana. Ibu Evi. Ah, tuh. Bu Evi. And then Ibu Lia. Logistik section. And then Bu Imas also, tuh. Ah, Ibu Imas. And then all the technical crew, Harpra, Nugraha, Dada dong. And then Fauzan, wis, Brian, oh, Prabu, wis, Faki, Robi, skip. All the thank you and all efforts that we would like to thank to Mr. Robi. He's the super admin of this 3 days event, yeah, including preparation. So thank you, Pak Robi, Arifandri, our master of super admin in the Zoom, WhatsApp, Medsos, and all things. Super admin. Thank you, thank you. Terima kasih banyak. Assalamualaikum warahmatullahi wabarakatuh.